Okay, so here we go. What are we on? Number 8. 10.3, number 8. And again, if you didn't have the picture, I apologize. Here we go. So it says, in the figure, a stationary block explodes into two pieces, L and R, that slide across a frictionless floor, and then into regions with friction where they stop. Piece L, with a mass of 2 kilograms, encounters a coefficient of friction of 0.4 and stops in a distance of 0.15 meters. Piece R encounters a different blah, 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 blah. You got to find the mass of the other block. Okay, so this is the before, right? So here's block R, here's block L. So here's what we know. We know that the coefficient of friction on the right is 0.5. We know that the coefficient of friction on the left is 0.4. We know that the mass on the left is 2 kilograms. The question is, what's the mass on the right? All right, the other thing that we know is the distances they both slide. So this guy is going to slide a distance of 0.25 meters, and this guy is going to slide a distance of 0.15 meters. I think that's it. Cool? All right, so yeah, our total momentum has to add up to 0, right?
Yeah.
You guys agree with that? So that means that right after the explosion, the mass times the velocity of the block on the left has got to be equal and opposite to the mass times the velocity of the block on the right. Good? So we need to find a way to figure out some information about, I feel like we should analyze the block on the left because I know more about the block on the left, yes? What would be a useful thing to know about the block on the left? Acceleration and velocity, right? Okay, so when we say acceleration, Josh, what do you mean? The acceleration during the explosion, or the acceleration as they slide across the friction?
The acceleration due to the friction.
Due to the friction, right? The explosion occurs almost instantaneously, right? Okay. What we're more concerned about is the friction. Okay. So, any ideas about how I can use this garbage to find? So this is a use all the tools in your toolbox thing. Any ideas about how we can find the acceleration of that block on the left? Yeah, we got to make a three-body diagram. Okay. So here's the block on the left. So you're going to have force of gravity is mg. Normal force is also mg. Let's see, it's moving this way, so my force of friction is going to go this way, and it's going to be 0.4 mg. Follow? Right, coefficient of friction times normal force. So now I can do net force equals net force. So 0.4 mg equals ma. And the acceleration ends up being 0.4 g, which is 3.92 meters per second squared. I guess negative, right? No, actually positive, because it's to the right.
Oh, and then you gotta use 2a delta x. Oh, it sucks.
It does suck. All right, are we good up to there? All right, so now there's two ways you could do this. Option one is you could find the work done by friction, because now we know the force of friction, and we know the distance. That's not the way that I would do it, just because it doesn't seem as intuitive to me. I like Sebo's thought of using kinematics. Use 2a delta x. Okay. All right, so now we can do exactly that. So 2 times 3.92 meters a second squared times our delta x, which was 0.15 meters, right? Equals 0 squared minus vi squared, and solve for vi. Yes?
I did it another way. So I said the force of friction equals due to the
You can set the work of friction equal to the change in
Yeah,
kinetic
that's what I
energy.
meant.
Yeah, that's what I was just saying. And
Oh.
yeah. No, don't, sorry, that's okay, that totally works. And to be honest, in a sense, I like that better because we just came out of energy. But I think for most people, it's probably not the most intuitive way to do it. All right, so anybody know what this gives you? Anybody figured out?
Negative 1.08.
Negative 1.08. And I agree, yes, it does have to be negative. Notice the equation doesn't tell you that, right? Cool? All right, so now you repeat that same process for the other block. The fact that we don't know the mass doesn't matter, though, right? Notice I didn't use the mass of this block because I canceled them, right? Follow? All right, so by the same logic, let me squishify this, let's see. All right, so if we do the same thing with the other block, notice this acceleration was just coefficient of friction times g, right? So same logic tells us that the acceleration of the other block should be 0.5 times 9.8, so 4.9 meters a second squared. So you can find your VI for that one, right?
Wait, how did you end up without a mass there?
They cancel out.
How did I end up without a mass here in the black or over here in the red?
On the red.
Well, we don't know the mass of the block on the red, or the mass of the block on the right, right? Correct? But notice here, I never plugged in my mass, but they canceled out here when I did net force equals net force. Follow? Everybody good? All right. So you go through the exact same process and you find the acceleration of the block on the right, and it gives you 0.49. So we can use that to find the initial velocity of the block on the right. So I guess I should have called this left and this right. So I don't know. Anybody know what it gives you? 1.56. Using the exact same, I almost said the word methodology and then didn't. And then totally undid by not saying it. Everybody good? All right. So now isn't it true that these two momenta have to be equal and opposite? So 2 times 1.08 equals m times 1.56. I guess if you wanted to do it using what I've told you, like we're trying to be consistent, right? So it's total momentum before equals total momentum after. Total momentum before is 0. Total momentum after would be mass times velocity plus mass times velocity. And solve for your mass. Cool? All right. We are out of time. We hit, I think, just about everything. I want to talk about those graphs tomorrow, all right? Do you guys want... 1.4 is significantly longer than 1.5. 10.4 is significantly longer than 10.5. Do you guys want to split 10.4 up so not all of it is due tomorrow? Yes? All right. Hold on. Hold that thought. Let's do this. 10.5 literally has 5 questions. So why don't we just make... I don't know. Why don't we just make 1 through 7 due tomorrow, and then we'll make the rest due Thursday? Does that help? All right. Okay, so we'll do that. And I'll also hit the other ones that I didn't get today.